Good morning, students. Good morning. My name is Mr. Ola. I'm here to present our last topic in mathematics for SS3 students. The last topic we'll not be able to finish before people left. But today, I'm going to start the topic from beginning by God's grace, and I'm also going to end it. The topic is longitude and latitude. This longitude and latitude is talking about 4 directions that have given 4 locations. The first direction is west, which is W. The second direction is east, and the third one is called north, and the last one is called south. These 4 directions have different locations. And before we know that west and east, the two of them are called longitude. Anything from west and east, we call them longitude. Anything north and south are called latitude. That means we have 2 longitude and 2 latitude. Okay, after that, we now move down to the formulas. In mathematics, without formulas, we cannot do anything. Without formulas, we cannot be able to do anything in mathematics. So that these are the formulas we need to work on this topic. The first one is the radius of the parallel of latitude. When the question says you should find the radius of the parallel of latitude, you have to apply small r equals to big R cos theta. And the second one says the distance along the parallel of latitude or small circle. You also to apply theta over 360 times 2 pi small r. And the third formula says the distance along the great circle or along the meridian, or in case we have 2 latitude or the shortest distance or equator, we have to apply theta over 360 times 2 pi big R. The difference between the small r and the big R is this capital letter R. This one has a capital letter R. This one has a small letter R. Also, we have the fourth one, which is formula of circumference. If the question says you should find the circumference, you have to apply 2 pi R to find your circumference. And the last formula is when we have to find speed. We already know the formula of speed. Speed says distance over time taken, and distance is equals to speed times time taken, and time taken equals to distance over speed. And also, you can say we have location of places and the operation of an angular difference or an angular sum. In longitude and latitude, we have a time to add, we also have a time to subtract. When we have the same locations and we have different, let's say we have the same location. With number 1, we have west and west, which is W and W. We have to subtract. We are what? To subtract. I repeat myself. I said when we have the same location, you can see this west together with west. Let's say we have 20-degree west and we also have 40-degree west. What type of operation we are supposed to apply there? We are supposed to subtract, which is 40 minus 20. Let me give another example again. Let's say we have 10-degree west and 15-degree west. What to do, because 2 of them have the same locations. So that what to do, we have to say 15 minus 10. So that our angular aspect will be 15 minus 10, which is 5. And the second one, let's say we have north and north, which is NN. We also to subtract. We have to subtract because 2 of them are the same location. And the third one is when we have south and south. we also, which is xx, which is the same thing as we are to also to subtract as well. When number 4, when say we have east and east together with east, which is w, which is e and e in brackets, we are also to subtract. The summary of this is that I says anytime we have the same locations in longitude and latitude, what we have to do, the operations we have to apply is we have to subtract the two angular that be given to us. The fifth one says, let's say we have west and east. West and east. You can see this one is a two different locations, which is W and E. We have to add, we have to apply addition. We have to sum them together. Let me give an example. Let's say we have 10 degrees west and 20 degrees east. You can see the two of them are longitude, right? We have one in west, we have other one in east. So that 10 degrees west and 20 degrees east. So that what are we supposed to do? The angular of that operation is supposed to be 30. We have to add them up. And this last one, let's say we have north and south. North and south, which is N and S. We also to add, to apply addition. Like I said, you can see that anytime you have the same locations, you should do all yourself. What you are supposed to do is to do your subtraction, to work your subtraction there. And when you have different locations, you have to add them up. That's only thing we know. So that we now go for the exercise. You now go for the exercise of solving questions. I have some practice questions here. We have some practice questions here. I want to give you some questions to work on so that we can see. My question, I'm giving you example 1. I'm giving an example 1. The question, okay, let me quickly clean the board so that we can see how the question look like. Question number 1. The question number 1, let me say example 1. We have example 1. 2 times, let me say 2 times P and Q lie on the equator and their longitude are 90 degrees east and 55 degrees east. Find the distance between P and Q. Find the distance between P and Q. Find the distance between P and Q. I repeat myself. I'm repeating the question again. The question says 2 times P and Q lie on the equator and their longitude are 90 degrees east and 55 degrees east. What I want us to look at the question, look at the key point of the question. The first location is 90 degrees east, and the second location is 55 degrees east. I want to say something. I said, don't forget that I said something on our tabular table here. I said, when you have the same location, what are you supposed to do? We have to subtract the two. The question says, find the distance between P and Q along the great circle. Find the distance between P and Q along the great circle. Don't forget that if you look at my formula 3 I gave a formula to find the great circle, which is theta over 360 times 2 pi big R. I repeat myself. Theta over 360 times 2 pi big R. Because the question says find the distance along the great circle, which is P and Q. So that the two directions we have here, we have 90 degrees east and 55 degrees. What we are supposed to do, we are supposed to sketch first. You sketch your diagram. You can see I'm sketching it on the board. I'm sketching my diagram on the board. I'm sketching it. You can see. You have to first sketch out your diagram. It's part of your marks. So that I'm sketching it. This one is west. This one is east. This one is north. And this one is south. Thank you. The first location says 90 degrees east. Where which side is east? You can see in my right hand side is the east. So that we now move it down. We sketch it out, which is 90 degrees. And when we have sketched it, we label it, which is 90 degrees east. You can see. Don't forget I said east and west are longitude. North and south are latitude. That means it's coming down like this. The direction becomes, the sketching of direction becomes like this. And the second one, the same location again, which is 55 degrees east. So that you sketch it out also. You sketch it out. And you also label it, which is 55 degrees east. Don't forget that the first one we sketch, make it complete circle. Just complete that circle, complete it. And the second one also, complete it as a full circle. Thank you very much. After you have done that, what to do? You know that in the question, they mention 2 points, which is point P and Q. Point P and Q. This point and Q, we have to know their what? Their angular aspect. What to do? That means we have to bring out our longitude so that we can easily know their meeting point. When the P point and Q, when they are met, when they are joined together with the angular aspect. So that what are we supposed to do? We have either we bring it to the north or we bring it down to the south. But let us bring it down to the north. We can also do that in south. You can see, I bend it. Anytime you want to make a longitude, you bend it like a circle. Or south as well, you bend it. Imagine I bend it like this, complete it as a full circle. Complete it. And if you look at the big dragon we have here, you can see a sign we have at the center, which is a plus sign. You also have the plus sign in this smaller one that you made. Good. And the first meeting point is this. The first meeting point is called point P. And the second meeting point is called point K. And their angular aspect is this. We bring it down. This is their longitude, you bring it down. And this place will be your theta. This is sketching of this question. I want to repeat the question so that I can get it well. Let me quickly go back again so that I can get the information well. The question says, two tan P and Q lay on the equator. Lay on the equator, and their longitude are 90 degrees east and 55 degrees east. The question now says, find the distance between P and Q along the great circle. Find the distance between P and Q along the great circle. And don't forget, when you see a question, the first thing you have to do is this. First, know your operational aspect, whether you are subtracting or you are. This question now, we have then the same location. We know that we are subtracting it. So that subtraction will be our theta, which is 90 degrees minus 55 degrees. And 90 degrees minus 55 degrees, the result is going to be 35 degrees. Our answer will be 35 for the theta. And we are supposed to know the formula to solve the problem. The formula is theta over 360, the distance along the great circle, which is theta over 360 times 2 pi big R. This is the formula. And I've already sketched the diagram, the way it's going to look like. You can see, when I started sketching it, I first indicated my 90 degrees east. After that, I moved to my second location, which is what? 55 degrees, and I labeled them. And I brought the issue of latitude to know where the two angular join together. So that after that, we now trace them to the center of our latitude. You can see the two. And the middle here is called theta, the angular aspect of what we are looking for. So that if you want to solve this problem now, what to apply is theta over 360 times 2 pi. So that I'm solving the problem now, which is L equals to, D equals to, our theta now is 35 degrees. Our theta is 35 degrees over 360 times 2 pi big R. 2 pi big R. And if you know that in mathematics, when we have pi simply means 22/7, and big R is called 6,400. Don't forget, anytime you come across big R in this, we change it to 6,400 because it's fixed already. Is what? Is fixed already. So after that, what to do? We now work on the calculation, which is what? D equals to 35/360 times 2/1 times 22/7 times 6,400 km. Don't forget to be adding your km. Km simply means distance. So that what to do now is to work on the simple calculation. You can see that 2 here, 2 goes there 1, 2 goes there is 180. And think of 2 goes in 22, which is 11, and 2 goes in 180, which is 90. So that let's look at what goes in 35 also goes in 90. Let us look at the calculation of what goes in 35. 5 goes in 35, and the 5 also goes in 90. How many 5 goes in 35? Which is 7. 35. Let me write it out so that we can 35/90 times 11/7 times 6,400 km, which is our kilometer. So that we are working on the final calculation now. What to do now? Think of what goes in 35 also goes in 90. 5 goes in 35, which is 7, and then 5 goes in 90. 5 goes in 9, 1, remainder 4. 4 will be added and make it 40. How many 5 goes in 40 is 8, which is what we have finally there. We have 7/18 times 11/7 times 6,400 km. So that we are working on this calculation. You can see what goes in, what can we work? 18. There are some 2 goes in 18, 2 goes in 6,400. So that 2 in 18, which is 9. 2 in 6,400. 2 goes in 6, 3. 2 goes in 4, 2. 0 will join. So that we finally multiply 7 times 11 times 3,200 kilometer divided by 9 times 7, which is called 63. So that we can simply apply our small calculation and work it out. By the time we work on this, 7 times 11 times 3,200 divided by 63. So that what we are going to have as final answer there, we are going to have something like, as final result, we are going to have 3911.11 km. So that this result, our final answer now for this now be 3911 kilometers. That's going to be the final answer for this.
Oh yeah.
Okay, you can see that. Giving another second example. The first one we have done, we work on operation of subtraction. So that this time around, I'm giving another example based on the addition. The question I'm giving now is also 2 terms, A and B have the same longitude and their latitude are 20 degree north and 31 degree south respectively. Calculate, the question says calculate the distance, calculate the great circle distance between them. I repeat myself. The question says 2 terms A and B they have the same longitude and their latitude are 20 degree north. Let me summarize on 20 degree north and 31 degree south. You can see through this direction we have them in different locations. We have one in north and the other one in south. The question now says calculate the great circle, the distance between them. We want to find the distance along the great circle of the two. So that we all need, what we need first is we already know the formula to apply, because we know that the question says find the great circle. So that our formula is theta over 360 times 2 pi big R. And the operation we are to apply, don't forget, we are to apply by adding 20 degree plus 31 degree, so that the total angle will now have 51 degree. So that the next thing to do is to work on the sketching of the diagram. You can see I'm trying to sketch out the diagram. I'm sketching it out. You can see I'm trying to sketching out the diagram. This one is west, this one is east, north and south. Very good. Don't forget I said north and south are called latitude. And if you want to sketch it out, the first one is 20 degree north. I'm sketching it out. 20 degree north. Look at my sketching. You have to bend it like you are trying to form a circle and bend it up. And after bending it, you complete it as a full circle. And you also label it, which is 20 degree north. And don't forget I said something. In this bigger circle we have, what we have in the center, just like a plus sign, so that you must also have the plus sign in the longitude. You can see we have a plus sign there. And the second one, we have it on south, which is 31 degrees south. We come down again. We come down, we bend it like a circle. We complete the circle. And we indicate a plus sign at the center. And we label it, which is 31 degree north. Good. Don't forget the question says the points are between A and B. The points are between A and B. So that we have to indicate where the A is and where the B is also is. So that you can see what we are going to do before we can get the meeting point of A and B. What to do is to introduce our longitude so that we can easily get our meeting point of A. This is the meeting point of A. We label it, and this one is a meeting point of B. We also label it. Thank you. After that, you can see that we have two latitudes, one up, one down. If you want to know their angular aspect, you bring them, you trace it to the center of the circle. The center of the circle. We cannot take all the two to the up. If we take it to the up, down will not take anything. If we take it down again, up will not take. So it's better for us to take it to their source. This is their source angle, and you label it. This is the angle. Thank you very much. This is a full sketch of the equation. Let me quickly repeat the question so that I can get to it. The question says, two tangents A and B have the same longitude, the same longitude. We can also complete this as a full circle as well. Have the same longitude, and their latitude are 20 degree north and 31 degree south. You can see my the first 20 degree north, and the other one is 31 degree north, 31 degree south. 31 degree south. So that what to do now is to work on the calculations so that we can get the final result for this question. How do we going to work on calculation? I've written the formula we are to apply. We already know the operation we are to work on, which is 51. So that I'm working on it now, which is going to be D equals to our theta now is 51 degree divided by 360 degree times 2 over 1 times 22 over 7 times 6,400. I told you that 6,000. The reason why we are adding the km simply means unit of distance. Unit of what? Distance. So that you can see, we can work on the calculation now, which is 2 here, 1. How many 2 goes in 360? Which is 180. And 2 goes in 22 as well. 2 also goes in 180, which is 90. So that we can say, we can also work on this, 6,400 here. So that you can see 2 goes in 90, which is 45. 2 goes in 6,400, which is 3,200 kilometers. So that we can write as D equals to 51 over 45 times 11 over 7 times 3,200 kilometers over 1. So that you can see that in 51 and 7, nothing goes there. 7 cannot go in 51 accurately. And if you look at this, okay, in 45 and 3,200, 5 goes there. If your 5 goes in 45, which is 90, 5 goes in 32, in 30, which is 6. Remember 2. 2 will be added there, make it 20. 5 goes in 20, which is 4. Is that what we come up, which is 640 km we have there. So that, let me quickly work, let me write on the board so that you can see at the up. So that theta now equals to 51 over 9 times 11 over 7 times 640 kilometers over 1. So that what to do? Nothing can go. What to do is to multiply all the numerators together. We also to multiply all the denominators together. So that the D now equals to 51 times 11 times 640 km divided by 63. So that if you work on D, you multiply 51 times 11 times 640 kilometers divided by 3. The result we are going to have as the final answer, you are going to have 5, 6, 9, 8. 5, 6, 9, 8 kilometers. I repeat, if you have to work on the multiply by using your calculator, 51 times 11 times 640 kilometers divided by 3, what you are going to have as the final result there is 5, 6, 9, 8 kilometers. That's going to be the final answer for this, for the second question. So that for out of all the formulas I've given for this longitude and latitude, I gave about 5 different formulas to use, but I've used one and I've also given the 2 exercises on that one, which is number 3 formula. So that I'm moving to another formula to apply by giving a new question. Okay, I want to clean the board and give another question on by using another formula on it. Okay, I'm also giving, that will be my third example for today. Example 3. Example 3. The question I'm giving now, based on distance along the parallel of latitude. Distance along the parallel of latitude, which is my formula 2. Distance, how to calculate distance along the parallel of latitude, which is formula says theta over 360 times 2 pi small I. This is number 2 formula I've given out. So that I want to use this formula to work on this exercise I'm giving out. So that the question says, the question is this. The question goes like this. Okay. The two tan R and X are on latitude 60 degree north. I repeat myself. The question says 2 tan R, 2 tan R and X. 2 tan R and X are on latitude 60 degree north. Are on latitude 60 degree north, and their longitude are 35 degree west, 35 degree west, 35 degree west, and 25 degree west as well. Respectively, the question now says calculate the distance, calculate the distance along the parallel, calculate the distance between tan R and S, calculate the distance between tan R and S along the parallel of latitude, along the parallel of latitude. This is the question I'm giving at the third example for today. Let me quickly go through the question again so that you can get the information well. The two terms, we have two terms says R and X are on latitude 60 degree north and their longitude are 35 degree west and 25 degree west also respectively. Calculate the distance between tan R and X along the parallel of latitude. Don't forget I said anytime they ask to work on along the parallel of latitude, along the parallel of latitude, you have to apply theta over 360 times 2 pi small r. This time around, not bigger again. This time around, we are using the small r. So that what to do now is to fairly work on the angular aspect. What's the angular aspect? We have two latitude, we have 35 degree west and 25 degree west. So that you can see the two west we have them the same locations. The two directions are the same location. So that if you have them the same location, what to do is to subtract. Which is 35 minus 25. So that our angular aspect will now be 10 degree. Thank you very much. And also we have to sketch out the diagram. How will you sketch out the diagram? So that you can see. You need the sketching of the diagram. Okay, this is our full circle. We sketch it out so that this side is west, this side is east, this side is north, and the last one is south. The question was, we have a latitude of 60 degree north. So that where is the north side? Up. We know that it's up side. Our north is up. So that we bend it. As if we are forming a circle, we have done that, and we must complete it as a full circle. And don't forget, I said something at the center here. We must indicate as a plus at the center. You can see a plus, so that we label it as 60 degree north. Thank you. The two longitude we have 35 degree west and 25 degree west as well. So that we have to indicate there. So that 35 degree west, you can see my west. This side of my west, you can see I'm bringing it down. Label it 35 degree west. And the second one is also 25 degree west as well. The same location. You can see west as well. Good. You can see you also label it as 25 degree west. Thank you. And I told you about something sketching, that when you are sketching your diagram, make sure you sketch a full circle, the first one and the second one as well. Thank you. And also the meeting point of R and S. R is the first one. The first one is this, which is your R. The second one is this, which is your X. So that you indicate them to their equator. You can see Good. And you indicate your theta here. Theta is the angle you are looking for. This is full sketch of this question. So that what to do is to simply work on the calculation, how to work it out. If you want to work it out, don't forget that I've given you the formula. The formula is this: theta over 360 times 2 pi small r. The reason why we are using this formula, because I said anytime they ask you to work on distance and along the distance along the parallel of latitude. Distance along the parallel of latitude. This question says find the distance between R and S along the parallel of latitude. You have to apply this so that you can see. Let me quickly work on the calculation. The calculation is this, so that we now use it. Okay, which is D equals to our theta. Don't forget our theta. Our theta is 10. So that 10 over 360 times 2 times 22 over 7. This small r is the radius. The small r called radius of the parallel, radius of the parallel of latitude, radius of the parallel of latitude. So that this formula, what to do, I don't forget the formula I gave as number one formula. The formula says small r equals to big R cos theta. Don't forget, that's number one formula I gave. I say the small r simply means equals to big R cos theta. So that we're going to apply the same thing here. So that for us to substitute for this small r, we have to do the small calculation here, which is our small r equals to big R cos theta. So that small r equals to what? Our big R, don't forget, our big R is 6,400 km times cos that latitude we have in the question. The latitude was given to us in the question is 60 degrees north. We indicated it. Don't just write 60 degrees, put it as north together. So that we now say small r equals to 6,400 times cos 60. Cos 60, what we are going to have as cos 60. Cos 60 will give us, cos 60 is going to give us cos 60 we are going to have is 0.5. Cos 60 will be 0.5, which is half. So that by the time you multiply 6,400 times 0.5, can you tell me what to have? So that what we are going to have, just like 6,400 times half. So that 2 here 1, 2 here 3, 200. So that our answer is 3200 kilometers. 3,200 kilometers. So that let's go back to our distance now. Our distance now, because we have something to substitute for the small r now, which is d equals to 10 over 360 times 2 over 1 times 22 over 7. Our small r. Don't just write this result out. It's part of your marks in WAEC marking scheme. If you are to just write small r is 3,200 kilometers, you will not be able to get your full mark for the question. What you are going to do, just start from 6,400, start from this step. Don't just write the result. If you write this result, not that you are wrong, you are still perfectly correct. But one thing is that examiners, they are not going to give you your 2 marks. You will be deducted by 2 marks there. So that's why it's very good when you are solving something like this, you work on with experienced teacher. So that this one is 6,400 kilometers times cos 60 degree. Cos 60 degree no. You have gotten it already. But only thing you just need, the examiner needs from you is that you just repeat what you have here. This one you have here will be what? Will be repeated here as well. So that our 10 over 360 times 2 over 1 times 22 over 7 times, you cannot write the result, which is 3,200 kilometers over 1. Good. Because you have gotten your 2 marks here already. Examiner like that. Examiner, they love that. So that you have gotten your 2 marks here. Don't just move to the final result and place it there. You will be judged by 2 marks. So that what we are going to do next is by cutting it or reducing it to its lowest end. So that 2 here 1, 2 here is 180. I cut 0 with this. So that 2 here is 11 and 2 here is 9. Good. So that what we finally have in our working here is 1 over 9 times 11 over 7 times 3,200 kilometers over 1. Like I said, kilometer is a unit of distance. So that what to do is to just multiply 11 times 3,200 divided by 63. So that 11 times 3,200 kilometers divided by 63. What we are going to have as the final result here, we are going to have our final result now. We are going to have 3,352 kilometers. So that one will be the final result for this. That is the end of example 3. So that okay, like I said, these 4 calculations, like what we have done before, we have made a simple mistake here. By the time we multiply 11 times 3,200 kilometers divided by 3, 11 times 3,200, it will give us 35,200 divided by 3. So that our final answer here will be 558.73 kilometers. And the final answer to the nearest whole number, we are going to have 559 kilometers. So that what I'm giving now, I want to give another example based on the distance along the parallel of latitude. Another question based on this. Let's see. Okay. The next question now, which is going to be our example 4 for today. The example 4 for today is going to base on distance along the parallel of latitude. I'm giving another question. We have another question says 2 points. Example 4. This is the 4th example. 2 points. 2 points P and Q. 2 points P and Q. 2 points P and Q on the Earth survey. On the Earth survey, so that on latitude on latitude 50 degree north, on latitude 50 degree north, their longitude are 20 degree east, 20 degree east, and 95 degree east as well. Respectively. Calculate. Question say calculate the distance. Calculate the distance PQ. Calculate the distance PQ along the parallel of latitude. That's question number A. 2. I'm taking it as A. 2. Question number B. It's like we are going to have 2 questions in this. Question number B. The question says, B says, if if it takes a plane 7 hours, if it takes a plane 7 hours to go from P to Q, what is the speed of the plane? What is the speed of the plane? What is the speed of the plane? Like I said, let me quickly go through the question and say. The question says, example 4 says, 2 points P and Q on the Earth surface are on latitude 50 degrees north and their longitude are 20 degrees east and 95 degrees east respectively. The question now says, calculate the distance PQ along the parallel of latitude. Which is question number 4A. 4B, the question also says, if it takes a plane 7 hours to go from P to Q, what is the speed of the plane? What is the speed of the plane? You can see the question number 4B. This question number B is talking about the fifth formula that was given to you. It's talking about the fifth formula that was given to you, which is speed equals to distance over time. So that what to do now is to first we sketch. After sketching, we are going to know the operation we are going to apply, angular operation, whether we are subtracting or we are adding. So that the formula we are going to apply for A, we all know that for A alone, we are to use theta over 360 times 2 pi small r. And also, don't forget this small r. Don't forget the formula for small r is equal to small r equals to big R cos what? Theta for the small r. We have done that in example 3. And also for the B as well. The formula we have to apply because we are looking for speed. Speed equals to distance over time taken. In any question of mathematics, you must take note of some things. Number 1, know the right formula to apply. The right formula to apply and the right operation you have to use. What type of operation is this? Are you subtracting or you are adding? Okay, you can see that in this question now, what we have to do, if you want to first work on the first question, which says calculate the distance PQ along the parallel of latitude. So that what to do, we already know the formula, theta, but we have to work on the radius of the parallel of latitude because of the small r we have in the formula. We have to first work on that, which is small r equals to big R cos theta. So that our small r now equals to big R now equals to 6,400 kilometers times cos 50 degrees. That's only latitude we have, 50 degrees. Our latitude is 50 degrees, which will go for that cost. So that R now equals to 6,400 kilometers times cos 50 degrees. Our cos 50 degree, I'm coming back to cos 50 degree. Our cos 50 degree, we are going to have cos 50 degree, we are going to have 0.54 0.6428 for cos 50 degree. Cos 50 degree. So that by the time you multiply them together, the result we are going to have for the two, the result will now be I'm coming for the result. And by using the normal formula we are supposed to apply for solving that equation 2, which is theta over 360 times 2 pi small r. Our theta, don't forget the theta. Our theta is what? The theta now, we have 2 theta. This first theta, we go for the latitude. Second theta, we have in the distance, we go for our theta there will now be, let's look at what we have as what? Longitude. We have 95 degree east, we also have 20 degree east. So that we have them the same location. And when you have the same location, the law says that we should subtract. We should what? Subtract. So that if we want to subtract it, we have 95 minus 20. 25 minus 20. We now have 65. We have 65. 95, we have 75. We have 75. We have 75. And the answer for here, we have 4113.92. So that by approximating it to the nearest whole number, if you want to approximate it to the nearest whole number, for the area of the Bible, what we are going to have, we have 4114 kilometers to the nearest whole number. So that you can see, by coming back to the question about A, really, we have gotten our small r already. We already have the result down. And the theta we have here, we also have it down, which is 95 minus 20. We now have 75 degrees for the angular aspect of this theta. So that D now equals to 75 over 360 times 2 over 1 times 22 over 7 times, don't forget our small r. Our small r is supposed to be, but we are not going to write this figure here because of the 2 marks that we have in this, because of the 2 marks we have here. The 2 marks we have here is very, very important. Just write, put your result here. You are still coming back to write it, but not yet. Work on the from beginning, which is 6,400, okay, times cos 50 degree north. Thank you very much. Over 1. So that our D now equals 75 over 360 times 2 over 1 times 22 over 7 times, by the time we multiply this, we have gotten the result, which is 4114 kilometers. Thank you very much. So that we now reduce to its lowest term. We are reducing it now. 2 here, 2 goes there 1, 2 goes there 180, 2 goes there 11, 2 goes there 90. So that what we are now having now is 75 over 90 times 11 over 7 times 4114 kilometers over 1. So that for me to continue with the working here on the other side of the board, let me clean up of the question. So that, okay, now look at it now. From where we stopped there, we know that we have D equals to 75 over 90 times 11 over 7 times 4114 kilometers over 1. So that what goes in 75, 5 goes in 75, 5 also goes in 90. 5, many 5 goes in 75, 5 goes in 7, 1, remainder 2, 5 goes in 25, 5. And then 5 goes in 90, 5 goes in 9, 1, remainder 4, make it 40, 18, times 11 over 7, times 4114 kilometers over 1. So that you can see that something goes in 15 again, also goes in 18. We can still continue reducing it. So that we have D now equals to, you can see 3 goes in 15, 3 goes in 18. 3 in 15 is 5, 3 in 18 is 6. So that we have 5 over 6 times 11 over 7 times 4114 kilometers over 1. So that you continue reducing it, because mathematics is about working in steps. You can't just bring your final result there. You will miss a lot of marks. So that the steps, they are very, very important in mathematics. You can see that I'm moving from one step to another, so that you can be able to have your full marks. So that our D now, we can now multiply them, which is 5 times 11 times 4114 kilometers divided by 67. 7 times 6 is 50. 7 times 7 times 6, so that's 52, 56. 7 times 6 is 56. Am I correct? Oh. 7 times 5, 35. 7 times 6, 42. 42. 7 times 6 is 42. So that we now divide by what we now is going to be the final answer. So that let's see what's going to be the final answer for this. So that we have to multiply 5 times 11 times, so that our final answer will now be 2, 6, 2, 7, 0. Over what? Over 42. So that the final answer for this now, we have to divide 226,270 over 42. So that let's see what's going to be the final answer for this. Our D now for the final answer for the distance now, we have to divide 226,270 over 42. So that what to do, we have to divide by this. So that let's see what's going to be the final answer for this. Our final answer now will now be 5387. 5387. 5387.38. For us to take it to the nearest whole number, what will now be the result? You know the nearest number to 7 is 500 now. So the final answer is 5387 kilometers. For question number A. You know, don't forget that with the question I gave, we have 2 questions there. We have a question for A and a question for B. We have 2 with the question for A, so that we are not going for the B. And don't forget that in question B, I've given the formula we have to apply, which is going to say what is the speed of the plane. We have to find the speed of the plane, which where the formula we have to apply there is speed equals to distance over time taken. Distance over time taken. Don't forget that we have gotten our distance. We have gotten it already. And the time taken we have in the question is 7 hours. So that our speed now equals to distance, which is 5387 divided by 7, because the plane moved from 7 hours from P to K. So that by dividing this, our speed now for question number B, we now have 769.10. So that by working on the whole number now, we are going to have 769 kilometers per hour. Hour. Because we are working on speed. We are going to have it in kilometers per hour. So that we have, out of all the five formulas I gave for this topic, we have applied about 4 formulas. We have applied 4 formulas. So the answer will be what? Okay, by making that whole number, we are going to have 770 kilometers. Round it up as 7, because this one is nearest number. It's rounded up as 1. By the time we add 1 to this, it will give us 770 kilometers. As I wrote, we have used like 4 now. We have worked on how to work on the radius of the parallel of latitude, the distance along the great circle, the distance between along the parallel of latitude 3, and the 4th one we have used the formula of speed. So that the only formula that's remaining now how to work on circumference, which is 2 pi r. So that by the time we have our next class, we are going to continue from where we stop. So that